How can you trust your own morning coffee cup when you are actually living in the past? As you reach out to grab it, you see the steam rising and feel the ceramic warmth, watching your hand move in what feels like perfect real time. This sensation of a live broadcast is a trick of the mind. Every single thing you see, hear, and feel has already happened by the time you experience it. Your brain operates on a 15-millisecond processing delay. This means your consciousness trails behind the physical world like a slow-moving shadow. To hide this lag, your mind creates a best-guess hallucination of the present. It even invents colors like magenta that do not exist on the light spectrum to bridge the gaps in your own biology. You have never actually seen the world directly. The light hitting your eyes right now is a chaotic storm of electromagnetic waves rather than a stable image. Before you can perceive the cup on your desk, those waves must strike the back of your eye, trigger chemical reactions, and travel as electrical pulses through thick bundles of nerves to the back of your head. This takes time. In 1867, Hermann von Helmholtz realized that if our brains simply waited for the data to arrive, we would be too slow to survive. We would fumble every catch and trip over every step. To solve this, your brain uses what Helmholtz called unconscious inference. It gathers the delayed data and builds a predictive model of what should be happening right now. You are watching a simulation constructed by a subconscious director. Think about the last time you looked at a ticking wall clock. Sometimes the first time you glance at the second hand, it seems to freeze for a split second longer than it should. This is a glitch in your internal software called Chronostasis. When your eyes move rapidly from one point to another, your brain briefly shuts off your vision so you don't see a nauseating blur. To prevent you from noticing a gap of total darkness, your brain takes the first clear image it sees after the jump and backdates it in your memory. It literally rewrites your history to make you believe you were looking at the clock for those missing milliseconds. Your sense of time is a polished edit instead of a raw recording. But the eyes are not the high-definition cameras you think they are. In the center of your vision, there is a physical hole where the optic nerve exits the eyeball. There are no light sensors there at all. In 1668, Edmund Marriott proved this to the court of King Charles Roman II. He showed that by closing one eye and focusing on a specific spot, a person could make a large object, or even a person's head, completely vanish into thin air. You don't see a black hole in your vision today because your brain looks at the surrounding colors and textures and simply paints in what it thinks should be there. You are walking around with two massive blind spots, and your mind is lying to you about them every second of your life. This internal lying goes even deeper when it comes to color. Sir Isaac Newton sat in his rooms at Cambridge in 1704 and realized that light rays themselves have no color. They only have different wavelengths. When you look at a red apple, there is no redness in the light hitting your eye. There is only a specific frequency of vibration. Your brain interprets that vibration and creates the sensation of color inside your head. If a tree falls in a forest and no one is there to see it, the leaves are not green. They are reflecting light of a certain frequency, but the greenness only exists as a mental experience. Color is a language your brain uses to label the invisible world. One specific color proves how much of your world is a fabrication. If you look at a rainbow, you will see red at one end and violet at the other. Physically, these are two opposite ends of the visible light scale. There is no single wavelength for magenta. However, when your brain receives signals for both red and violet light at the same time, it doesn't want to show you two separate colors. It wants a bridge since there is no physical color between them in the universe. Your brain invents one. Magenta is a biological placeholder for a gap in physics. It is a color that does not exist in the light spectrum, yet you see it as clearly as the sky. Scientists still can't fully explain why this reconstruction is so seamless. In 1959, David Hubel and Torsten Wiesel discovered that your brain doesn't even see objects at first. It sees edges, lines, and orientations. Your visual cortex takes these raw geometric scraps and assembles them into a face, a car, or a tree. It is like a detective at a crime scene trying to piece together what happened based on a few footprints and a broken window. You are never seeing the whole scene at once. You are only seeing the parts your brain decided were important enough to render into your consciousness. To put that in perspective, consider the work of Alfred Yarbus in the 1960s. He tracked the way people's eyes move when looking at a painting. He found that we don't scan an image like a photocopier. Instead, our eyes dart around in tiny, jagged jumps, sampling small bits of information. If someone asks you how old the people in a painting are, your eyes only look at the faces. If they ask how wealthy the people are, your eyes only look at the clothes. Your brain ignores almost everything else. You feel like you are seeing a complete, detailed world, but you are actually living in a low-resolution sketch that your mind has colored in with expectations. The strangest part of this phenomenon involves our inability to see changes. In 1997, researchers at the University of British Columbia demonstrated something called change blindness. They showed people two versions of the same photo, flickering back and forth even when massive parts of the image were changed, like a large airplane engine disappearing or a building changing color. Most people didn't notice for nearly a minute. This reveals a startling truth. You aren't actually recording most of what is in front of you. Your brain assumes the world is stable, so it stops checking the details. It relies on its own internal map rather than the actual light entering your pupils. If our eyes are this unreliable, it means our entire understanding of the universe is filtered through a biological lens that was designed for survival. Not for truth. We don't see the world as it is. We see the world as we need it to be. The specific biological mechanism that tricks you into thinking you see a continuous world is actually a series of frozen snapshots, edited together by a subconscious director. We are all living inside a beautifully rendered movie of the past, unaware that the real world is moving just slightly ahead of us. Forever out of reach, does a hole exist in the very center of your vision? To understand how your brain builds the world, you first have to find it. Right now, two physical gaps sit in your field of vision, each the size of a pinhead on your retina. This is the spot where the optic nerve plugs into the back of the eye. Because that thick cable of wires takes up the space, there are no light-detecting sensors there. No rods, no cones, and no data. By all the laws of physics, you should see two black, empty voids hovering in front of you like dead pixels on a television screen. Yet you see a seamless, unbroken horizon of color and detail. This biological quirk serves as the first clue that your brain is a master of deception. In 1668, a French scientist named Edmé Mariotte sat before the Royal Academy of Sciences and proved this gap existed with a simple piece of paper and a coin. He discovered that if you close one eye and focus on a specific point while moving an object into your peripheral vision, that object will suddenly vanish. It doesn't just go blurry. It ceases to exist. Mariotte even entertained the court of King Charles Roman II by showing the king how to behead his courtiers. By standing at a precise angle, the courtiers' heads fell into the king's retinal blind spot and disappeared. The part that should keep you awake at night involves how the brain handles that void. When the object vanishes into the hole, your brain does not show you a black patch or a blurry smudge. Instead, it looks at the wallpaper behind the object, the color of the sky, or the texture of the grass, and it simply paints over the hole. It performs a digital content-aware fill in real time, guessing what should be there based on the surrounding environment. You aren't seeing the wall. You are seeing a neural best guess of what the wall looks like. This process, which scientists call filling in, happens every millisecond of your waking life. The deception runs even deeper than a single blind spot. Your eyes are not steady cameras. They are constantly twitching in tiny, violent leaps called saccades, moving 3 times every single second. If your brain showed you the raw footage of these movements, the world would look like a nauseating, shaky home movie. To save you from this, Your brain simply shuts off the feed during the move. You are effectively blind for 40 minutes of every day, yet you never notice the darkness. Your mind stitches the still frames together so perfectly that you experience a smooth, continuous flow of time that does not actually exist in the light hitting your eye. In 1867, the German physicist Hermann von Helmholtz realized that vision is not a recording, but a form of unconscious inference. He argued that the data coming from our eyes is too messy, too thin, and too full of holes to be useful on its own. To make sense of the chaos, the brain acts like a detective at a crime scene. It takes a few scattered clues, a flash of red, a curved line, a hint of shadow, and it infers the existence of an apple. You don't see the apple. You see the brain's conclusion. It is a calculated narrative built from a tiny fraction of the available evidence. Consider the work of David Hubel and Torsten Wiesel at Harvard in 1959 to put the scale of this construction into perspective. They discovered that the neurons in your visual cortex don't even recognize objects. Some neurons only fire when they see a horizontal line, while others only care about a 45-degree angle. Your brain receives a frantic, disjointed Morse code of edges and orientations and has to somehow assemble them into your grandmother's face or a speeding car. It is a massive computational heavy lift, because it takes time to process. The image you eventually see is always a slightly outdated map of a world that has already moved on. Even the colors you perceive are a mental fabrication. In 1704, Isaac Newton wrote in his masterpiece, "Optics that light rays themselves have no color. A photon of light is just a wave of energy with a specific frequency. There is no redness in a 700 nanometer wavelength any more than there is music in a radio wave. The color only happens inside your head when that energy hits your retina and triggers a biological reaction." Your brain invented color as a filing system to help you distinguish a ripe berry from a poisonous leaf. Without a brain to interpret it, the universe is utterly colorless and silent. This led researchers like Edwin Land, the founder of Polaroid, to realize that your brain doesn't even care about the actual wavelength of light. In his experiments between 1959 and 1971, Land showed that if you change the lighting in a room, moving from bright sunlight to a dim yellow lamp, the wavelengths hitting your eye change completely. A green sweater should technically look brown or gray under different lights. But your brain performs a feat called color constancy. It compares every object in the room against every other object, subtracts the tint of the light source, and forces you to see green. It is lying to you about the physics to give you a consistent reality. How much of the world are we actually missing if the brain is so good at inventing what we see? In 1997, researcher Ronald Rensink at the University of British Columbia demonstrated a phenomenon called change blindness. He showed people two versions of the same photograph, flickering back and forth with a brief gray flash in between. In one version, a massive object, like an entire engine on an airplane wing, would be missing. Most people could stare at the image for a full minute and see absolutely nothing wrong. Because the brain only constructs a detailed, high-resolution image of the tiny spot you are looking at directly. The rest of the world is a low-quality sketch that your mind assumes is stable. We walk through life assuming we are seeing a high-definition movie of the universe. In reality, we are peering through a narrow straw, catching glimpses of a few details, and letting a biological supercomputer fill in the rest of the canvas with memories and expectations. This brings us to a haunting question that scientists are only now beginning to answer. If the brain is painting the sky and filling in the holes and inventing the colors, what happens when it gets the story wrong? The most dangerous part of this hallucination isn't what the brain adds. It's what it chooses to leave out. Could the very colors you see be nothing more than a sophisticated hallucination? Isaac Newton pondered this at Trinity College in 1704 while observing a beam of light pass through a glass prism. Most of his contemporaries believed color was a physical property of objects, assuming a rose was inherently red and the sky was naturally blue. Newton realized something that still challenges our basic understanding of reality. In his landmark book Optics, he wrote that the rays are not colored. There is no redness in a 700 nanometer wavelength any more than there is a sound inside a radio wave. Newton argued that light only carries a power to produce a sensation of color in the human mind. The vibrant world you see is a private performance happening entirely behind your eyes. To understand why this matters, we have to look at the rainbow itself. A standard rainbow displays a smooth transition from red to orange, yellow, green, blue, and violet. This represents the visible spectrum, which is the tiny slice of electromagnetic radiation our eyes can actually detect. If you look closely at that rainbow, you will notice something missing. Magenta does not exist in the rainbow. There is no single wavelength of light that corresponds to the color magenta. When your eye receives red light and violet light at the same time, your brain faces a problem. These two colors lie on opposite ends of the visible spectrum with no physical bridge between them in the outside world. Your brain hates a gap in the data. According to research from the University of Washington, our perception of color is a biological construct rather than a physical property of the universe. When red and violet hit your retina simultaneously, your brain refuses to see them as separate. Flickering signals, it invents a new sensation to bridge the distance. It creates magenta. This color is a pure mental fabrication, a bridge built by your mind to make sense of a physical impossibility. If you were to point a scientific instrument at a magenta flower, it wouldn't find a magenta wave. It would find two distinct, unrelated waves that your brain has decided to weld together into a single, beautiful lie. This isn't just a quirk of strange colors. It is the fundamental way we navigate the world. In 1867, the physicist Hermann von Helmholtz proposed a theory he called unconscious inference. He argued that vision is not a passive recording like a video camera, but a series of rapid-fire guesses. Your eyes are constantly fed messy, low-quality data. They have blind spots. They see in two dimensions, and they are frequently tricked by shadows. Helmholtz realized that the brain uses its past experiences to fill in these blanks before you even realize there is a hole. You don't see the world as it is. You see your brain's most likely explanation of what the world should be. Consider the work of Edwin Land, the founder of Polaroid between 1959 and 1971. He conducted experiments that changed how we think about the light hitting our eyes. He showed that if you change the lighting in a room by making it much redder or much bluer, the colors of the objects around you don't seem to change to your eyes. A green apple still looks green, even if the light bouncing off it is technically red. Land called this color constancy. Your brain isn't reporting the raw data of the light wavelengths. It is actively correcting the image in real time, stripping away the wrong light to show you what it thinks the object's true color should be. It is photoshopping your reality every second you are awake. Why would the brain go to all this trouble? The answer lies in the biology of the eye itself. In 1959, Harvard researchers David Hubel and Torsten Wiesel discovered that the cells in your visual cortex are incredibly picky. They don't just react to light. Some only fire when they see a vertical line, while others only react to a specific angle or a certain direction of movement. Your brain doesn't receive a finished picture from the eyes. It receives a chaotic stream of edges, dots, and motion signals. It has to stitch these fragments together into a coherent scene. The image you see of a friend's face or a park bench is actually a complex construction project managed by billions of neurons. We often assume that because we see something, it must be there in its entirety. In 1967, Russian scientist Alfred Yarbus proved that we are actually quite blind to most of our surroundings. He tracked the eye movements of people looking at paintings and found that they only sampled tiny fragments of the scene. The eyes dart around, grabbing a detail here and a color there. The rest of the complete picture you feel you are seeing is actually just a memory. Your brain takes those tiny samples and projects them onto a mental map. You feel like you are looking at a high-definition movie, but you are actually looking at a handful of snapshots held together by imagination. This leads to a phenomenon that scientists call change blindness. In 1997, researcher Ronald Rensink showed that people can miss massive changes in a scene, like a person changing clothes or a large building disappearing, if the change happens during a brief flicker or an eye movement. Because the brain is only sampling the world and filling in the rest with best guesses, it often fails to notice when the reality doesn't match the map. If your brain thinks the building should be there, it will keep seeing it for several seconds after it is gone. The map in your head is often more real to you than the light hitting your pupils. To put this in perspective, think about the sheer amount of information your brain is filtering out. The electromagnetic spectrum is massive, ranging from giant radio waves to tiny gamma rays. The portion we call visible light is less than 0.1% of that spectrum. We are effectively blind to 99% of the energy moving through the room right now. We don't see the Wi-Fi signals, the cellular data, or the heat radiating from our own skin. We live in a narrow, curated slice of reality shaped by millions of years of evolution to help us survive, not necessarily to show us the truth. If your brain is inventing colors like magenta to fill gaps, and if it is ignoring most of the energy in the universe to keep things simple, what else is it hiding from you? We trust our eyes because they feel like direct windows to the world. The deeper we look into the mechanics of perception, the more we realize those windows are actually screens. We are watching a highly processed, slightly delayed, and partially invented version of the universe. This raises a haunting question. If the colors we see are just a mental trick, what does the world actually look like when no one is watching? Why does the thin red hand of a clock occasionally freeze when you glance at it? You look at the wall to check the time, and for a moment that feels slightly too long. The hand sits perfectly still. This common glitch in your reality is something you have likely noticed 100 times without questioning the cause. Scientists call this chronostasis, a Greek term that translates to standing still in time. This is not a mechanical error or a lapse in your attention. It is a deliberate, calculated lie told to you by your own brain. To understand why this happens, we must examine what your eyes are doing every second of the day. Your eyes do not glide smoothly across a room like a professional film camera on a track. Instead, they jump, these lightning-fast movements. Known as saccades are the fastest actions the human body can perform, reaching speeds of 700 degrees per second. If your brain showed you the raw data from these jumps, your life would be a nauseating blur. Every time you shifted your gaze from a phone to a window, the world would smear into a chaotic streak of colors. To prevent this, your brain performs a radical act by shutting off your vision entirely during the jump. You are effectively blind for 40 minutes every single day, yet you never notice the darkness. This total blackout is called saccadic masking. It is a biological edit, a cut in the film of your life, because a gap in your vision would be just as jarring as a blur. Your brain performs a feat of temporal gymnastics to fix the hole. It takes the image you see at the end of the jump and stretches it backward in time to fill the void. When your eyes land on that clock, your brain pretends you were looking at it the whole time you were moving. It backdates the sensation. The first second feels longer because your mind adds extra time to the clock's position to cover its own tracks. In 2001, researchers at University College London measured exactly how much of our lives are fabricated in this way. Using a specialized light system to track eye movements with extreme precision, they found that the brain can trick you into thinking a moment lasted half a second longer than it actually did. This is a fundamental rewiring of your timeline. You are living in a reconstructed history where the present moment is constantly being edited to look seamless. The now you experience is a polished final draft rather than a live broadcast. This masking effect gets even stranger because it occurs every time you blink. You blink 15,000 times a day, and each time your eyelids shut out the light for 1/10 of a second. That adds up to over an hour of total darkness every day while your eyes are open. Yet you never see the world dip into black. Your brain suppresses the visual signal of the eyelid closing and fills in the blank space with a steady, unchanging image of whatever was there before. You are walking around in a world that is frequently dark while believing it is constantly bright. This raises a haunting question about the nature of our conscious experience. If our brains are willing to invent time and hide darkness to keep the story consistent, what else are they editing out? In 1997, Ronald Rensink at the University of British Columbia conducted a famous experiment on change blindness. He showed people two versions of the same photograph with one major difference, like a large building disappearing or a plane losing an engine. He flickered a brief gray screen between the two images. Even though the change was massive and right in front of them, most people could not see it for nearly a minute. Without a continuous stream of motion to signal a change, the brain simply assumed the world stayed the same and refused to update the map. We like to think of our memory as a video recording, but it functions more like a sketch artist working from a brief glimpse. Your brain is a master of efficiency that hates wasting energy on details it deems irrelevant. It relies on a concept called unconscious inference, a term coined by the German physicist Hermann von Helmholtz in 1867. He argued that vision is an active conversation rather than a passive recording. Your eyes provide a few scattered clues, and your brain uses its past experiences to guess the rest. It shows you the world as it most likely should be instead of how it truly is. This internal simulation is so powerful that it can override the physical reality of your own body. There is a small spot in the back of each eye where the optic nerve attaches to the retina. In this specific spot, there are no light-sensitive cells at all, meaning you are technically blind in the center of your field of vision. In 1668, Edmé Marriott demonstrated this to the French royal court by making a coin seem to disappear into thin air just by moving it into a person's blind spot. You do not see two black holes in your vision right now because your brain looks at the surrounding area and paints in the missing texture. It is a permanent, living hallucination. The deeper you look into the mechanics of perception, the more the floor seems to drop away. We are not observers standing behind a window looking out at the universe. We are more like pilots in a windowless cockpit, staring at a screen that displays a digital recreation of the outside world. The sensors are delayed, the pixels are sometimes filled in by internal software, and the clock on the dashboard is occasionally adjusted to make the flight feel smoother. Everything you have ever touched, every person you have ever loved, and every sunset you have ever watched has been a mental reconstruction. Scientists still cannot fully explain why this internal movie feels so incredibly real. We know how the neurons fire and how the light hits the back of the eye, but we do not know why that physical process turns into the vivid, colorful feeling of being alive. We are trapped inside a 3-pound organ that has never seen the sun, trying to make sense of a world it only knows through electrical pulses. This leads to the final, most unsettling realization of all. If our brains are creating the colors, the time and the continuity of our lives, what happens when two people look at the exact same thing and see two completely different worlds? Does the room where you are sitting right now actually exist in the way you perceive it? You see the texture of the walls and the specific shade of the floor. Yet this entire experience is a construction. Your brain is not a window. It is a storyteller. It takes a messy, delayed stream of electrical signals and weaves them into a smooth narrative that you can use. Hermann von Helmholtz called this process unconscious inference in 1867. He realized that we don't just see the world. We conclude it. Every object you look at is a best guess made by a 3-pound organ sitting in total darkness inside your skull. It is a controlled hallucination that happens to coincide with reality just enough to keep you alive. This realization changes the way you interact with every single thing you touch. When you reach for that morning coffee cup, you aren't just engaging with ceramic and liquid. You are interacting with a mental model that your brain projected into space milliseconds before your hand even moved. Scientists at the University of British Columbia have shown that we live in a state of constant change blindness. We assume we are seeing a complete, high-definition movie of our surroundings, but we are actually only sampling tiny fragments of data and letting our memory fill in the rest. You are navigating a map, not the territory itself. This explains why eyewitnesses disagree or why you can look for your keys while staring directly at them. The 4-kilogram mass of gray matter simply decided they weren't part of the current map. To see the world more clearly, you have to start by doubting the perfection of your own eyes. You can test this by paying attention to the edges of your vision. Notice how colors seem to wash out or shapes become blurry when you aren't looking directly at them. That is the raw data your brain usually hides from you. By acknowledging these gaps, you can train yourself to be a more deliberate observer. When you enter a new space, don't trust your first glance. Your brain is likely using a default template for what a kitchen or an office should look like. Take an extra 3 seconds to scan the room. Break the loop of your brain's predictions by looking for details that don't fit your expectations. There is a practical power in understanding that your mind invents colors like magenta to bridge the gaps in the light spectrum. It reminds us that our personal experience is not the universal truth. When you feel certain about something you saw, remember the thin red hand of the clock that stood still for too long. Remember that your brain is a master at smoothing over the cracks in time and space to give you a sense of comfort. This biological shortcut is a gift, but it is also a filter. It means that everyone you meet is walking around inside their own unique, reconstructed version of reality. We are all living in slightly different worlds, even when we are standing in the same room. Think back to that moment at the edge of the sink, watching the steam rise from your cup. You felt the warmth and saw the vapor swirl in perfect sync. Now you know that the warmth and the image were processed at different speeds in different parts of your head. Your brain performed a silent miracle to stitch them together so you wouldn't feel the lag. It created a seamless present out of a fragmented past. This doesn't make the coffee or the steam less real, but it makes the human mind much more incredible. You aren't just a passenger in the universe. You are the architect of your own personal cosmos. The next time you look at a sunset, remember that the vibrant purples and deep pinks aren't actually in the sky. There is no purple in a 400 nanometer wave of light. Those colors are a symphony played by your neurons to make sense of the collision between day and night. The world is far more chaotic and invisible than we like to admit. We only ever see the thin slice of it that our biology allows us to handle. We are surrounded by a vast ocean of energy and information that we will never perceive directly. We live our lives in the glow of a beautiful, necessary illusion. This brings us to a humbling conclusion about the limits of the human body. We often think of our senses as tools for discovery, but they are actually tools for simplification. If we saw every radio wave, every magnetic field, and every microscopic movement, we would be paralyzed by the noise. The brain's greatest trick is not what it shows us, but what it chooses to ignore. It filters out the chaos so you can focus on what matters. It creates a world of solid objects and steady time so you can navigate, survive, and wonder. You are the only creature that will ever see the specific version of the world you are looking at right now. Your vision is a fabrication, but it is a fabrication built on millions of years of survival. Every time you blink, your brain works overtime to make sure the world doesn't disappear. It holds the last frame of reality in a temporary buffer, waiting for your eyes to open again. It is a tireless editor, cutting and splicing a film that never ends. You have never seen the world directly, and you never will, but the version your brain creates is a masterpiece of biological engineering. It is a map so good that we often forget we are even holding it. As you move through the rest of your day, Try to catch your brain in the act of building your reality. Watch for the way a shadow turns into a solid object as you get closer. Notice how the world seems to snap into focus only when you pay attention. These small glitches are reminders of the incredible machinery working behind your eyes. The room you are sitting in is not just a collection of wood and plaster. It is a miracle of mental reconstruction. You are not just observing reality. You are participating in its creation every single second you are awake. The universe is a dark, silent place filled with invisible waves, and yet you experience it as a world of light, sound, and color. That transformation is the most profound journey you will ever take. And it happens entirely within the span of a few inches behind your forehead. We are explorers of a landscape that our own minds have drawn. The map is not the territory, but it is the only way we can find our way home. The next time you look into a mirror, remember that you aren't just seeing a reflection. You are seeing the final draft of a story your brain has been writing since the moment you were born. Subscribe, a new breakdown like this every day.